we'll have something like this on the test where you're just given shapes and I just say, name it as specific as possible. So looking at the first one has right angles. Think about that flow chart, that little diagram we had yesterday. Where did the right angles first appear at? On what shape? The rectangle. Then this one can only be a rectangle. Though it looks like a square, we don't know anything about the side, so this one has to be a rectangle. All right. The next one only has these parallel marks. Which one do you think this one would be? Parallelogram. All right. The next one has nothing. Quadrilateral. All we can say is that it has 4 sides. All right. Next one has all equal sides. Where does the all equal sides first appear at? On what shape? The rhombus. Good. And the last one has all equal sides, all equal angles. This one has to be the square. All right, good job. All right, when you're ready, we'll go over to the notes. All right, so the last piece we need is the trapezoids and the kites. The last thing we need. If we talk about just a trapezoid in general, just a trapezoid, the only thing we can say is that it has 1 pair of parallel sides. That's really the only thing we can say about your basic trapezoid. Just 1 pair of parallel sides. And those sides are called the bases, which you'll want to remember because we'll get to area, and the bases are going to be important when we're finding area of the trapezoid. The second part just says the non-parallel sides. These are called legs. So the sides that are not or do not have the arrows, that are not parallel, these are just called the legs. All right, and that's it. That's it for just the trapezoid, just 1 set of opposite parallel sides. But when we get to the isosceles trapezoid, then that one has more. So the isosceles trapezoid, if you think about an isosceles triangle, I'm gonna draw it over here. If you think about an isosceles triangle, we have 2 equal sides, and you also have 2 equal what? Angles. And where are those angles at? Across the legs. Good. So these 2 angles would be considered congruent. That ties in with the isosceles trapezoid. All it is, it's an isosceles triangle just split. It's just split up at the top somewhere. And if you look, you have 2 equal sides. They're also called the legs. And across these legs that are here, you have congruent angles. Now you have them at the bottom, but you're also going to have them at the top. Okay? So that's where the isosceles triangle and the isosceles trapezoid go in, kind of tie in together. Let me delete this real quick. If you don't want to do all those markings, you don't have to. You could also know that those angles are congruent because they're at the bases. So remember your base is at the parallel sides. So you have 2 bases. These are your parallel bases. On these lines specifically, those 2 angles are equal. And then these 2 angles are equal. All right, diagonals are congruent. The diagonals are congruent, but does it look like they're bisected? Does it look like they're cut directly in half? They're not. Now, we can say that these 2 are equal and these 2 are equal, but the diagonal itself is not bisected. It's cut into 2 parts, but not evenly. So with this one saying it's at the full diagonal, B to D and C to A, those are the full length. So that means if this is 5 and that's 10, and this is 5 and this is 10, A to C has a length of 15, and B to D also has a length of 15. That's what it means by the diagonals are congruent. So they're split, but just not in half. Focusing on those 2 triangles, and again, these are just things that you may notice, and I want you that if you notice it, it's true. What do you notice about these 2 triangles? What do you think? Do you think they're right triangles? No, right? They said nothing about it being perpendicular. Because this is isosceles, and if I was to come up and look at this property here, that the 2 legs are equal, if I added that, would that help you? What could we say about these 2 triangles? They're equal. If those 2 legs are equal, because this is isosceles, and these diagonals are split, not bisected, but they are split exactly the same, so the two tops are equal and the two bottoms are equal, then technically these are congruent by what reason? Side, side, side. Good. They are congruent by side, side, side. Just want to see that you see them. Do y'all notice anything else within this picture? Just trying to see, expand your brain a little bit. Do y'all notice anything else? Those two triangles are congruent. What about the top triangle and the bottom ones, the ones that are two different sizes? They're not congruent, but they're what? Isosceles triangles. These are also isosceles triangles, which means this angle is equal to this one, and this one's equal to this one. Will it be beneficial? I don't know, but if you ever need it, if y'all see those patterns, if y'all see those triangles, it could always help. All right, the last thing about the isosceles. A and C will equal 180, and B and D will also equal 180. There's also one more 180 that they don't have listed. And again, of course, this is only when you have isosceles. Coming back to this one, if I was to draw a line here and focus on these two lines, what do you think is true about these two angles? They'd have to add up to 180. These are consecutive interior angles. But unlike the parallelogram, right? Because the parallelogram, we had this, and we said those two equal 180, these two equal 180. We said these two and these two. Unlike the parallelogram, the isosceles only has the two different angles that are next to each other that would be considered supplementary. So those could also add up to 180. That's why when you're proving a parallelogram, that's why they don't use consecutive angles or supplementary. Because some shapes, like this isosceles trapezoid, does have that property. Not all the way around, but it does have it with some of the angles. All right, let's see what we can do with the isosceles. So with the regular trapezoid, you're not going to do much with it. It's going to be the isosceles one. So this one's isosceles. If you notice, the two legs are congruent. All right, and this is your base. What did we say about the base? How many angles are congruent here? 2. All right, so what other angle do I know? And y'all want to look at this picture up here. Look at this picture right here. If this is 108, what else is 108? Angle B, correct. Angle B here should be 108. All right, and then how do I figure out C? So this is the one I was just talking about. What should be true about B and C? Because we know these two have to be equal. The question is, how do I figure out the C? How would I figure that out? Subtract it from 180. 180 minus 108 would give us 72 degrees. All right. Let's go over to the right side. All right, it says if A to D is 2x minus 5 and B to C is 3x plus 7, find the value of x so that ABC is an isosceles trapezoid. So anytime it's read like that, so that it's an isosceles trapezoid, that means you're using one of the properties. What would be true about A to D and B to C? They're congruent. So I'm not going to make you solve it. We are going to set it up. This is how you would set up this problem and solve. They would be equal. Mind you, these are the legs. The legs on the isosceles trapezoid are congruent. Now they have to tell you it's isosceles, or you have to have something like this marked for you to assume it's isosceles. Okay? All right, next thing. They have the mid-segment of a trapezoid. We saw this with the triangle. Tying it into the triangle real quick. When we saw it with the triangle, we said that if we had a mid-segment parallel to the opposite side, do you remember what we did to figure out the measurements? If this was 10, what did we do to figure out the middle segment? Do you remember? We divided it by 2, and that gave us the mid-segment. Same thing here. The only difference is that you have 2 bases. That's the only difference. But the idea is still the same. You're going to look at the 3 parallel lines. In this case, your bases are going sideways, or not going sideways. They're vertical, not horizontal. So reminder that your bases are going to always have the arrows. These are your bases. So this is base 1 and this is base 2. And then this one here, this is your mid-segment. So all we're going to do is we're going to take our two bases, we're going to add them and divide by 2, and then that'll get you the mid-segment in the middle. This is part of the area formula that we'll get to in chapter 11. All right, okay, let's go to the back side. So looking at that formula, you're going to find the parallel bases, and they are here where the arrows are. And the formula says that we have to take base 1 plus base 2 and then divide it by 2. If you accidentally put B1 on top and B2 on bottom, it's not going to make a difference. They just have to be added, okay? So the formula says that I have to take 12, add it to 28, and then divide it by 2. So what's 40 divided by 2? M to N is 20. So you're just adding them and dividing by 2. All right, go ahead and try the one at the bottom. It's identical to it. Try the one at the bottom. All right, so what did we get here? What did we add? 6 plus 18? Equals 24. And what's 24 divided by 2? H to K should give us 12. All right, let's go over to this practice though. This practice, you're not finding the middle one, right? You're finding the missing angle. So remember the algebra, you always undo it by the last thing they did. So we're gonna take our two bases, we're gonna set it up the way we would if I was looking for the middle one, so B1, B2. So I'm gonna take X plus 18.2 divided by 2 gives me what? 15. You're undoing this. We kind of talked about this on one of those problems on our homework. How do I undo this? Multiply by what? 2. Am I only multiplying one side by 2 or one number by 2 or the whole thing? Has to be the whole thing. All right, now this side, on this side, the 2's cancel out. You're left with X plus 18.2 equals 30. All right, now what do we want to do with the 18.2? Just subtract it. All right, let's subtract 18.2. What's our difference? 11.8. All right, follow the same steps and try B. All right, so 20 plus X divided by 2 gives us 30. What are we going to do to the whole thing? We're going to multiply by 2. It's always whatever's in your denominator. This is going to cancel out on the fraction, so we're left with 20 plus X. What's 30 times 2? 60, and the difference gives us 40. Okay. All right. This formula is not on your formula chart, so you have to remember this one. Top plus bottom equals the one on the top plus bottom divided by 2 gives you your mid-segment, okay? So just the average. All right, last thing. Last shape. Properties of a kite. So with the kite, a lot of kids think a rhombus is a kite. The reason it's not is because it only has 2 pairs of consecutive congruent sides. So consecutive means it's the one that's right next to it. Kind of it with like consecutive angles, right? When we say consecutive angles equal 180. It's the one that follows it, the one next to it. So only these 2 are equal and only these 2 are equal. Now, the diagonals, like the rhombus though, they are perpendicular, which means that it makes what type of angle? 90 degrees. Let me put something here for y'all real quick. I'm gonna put the sides here. And shade in, we can do the shade the top one if y'all want. All right, let's see if y'all know the answer. What type of triangle is it? Isosceles, which means the opposite sides, the opposite angles of the sides have to be what? Congruent. That means that this side, or this angle, is congruent to this angle. So let me mark those for you in black. Those 2 are equal. Do you think it's going to happen with the bottom isosceles? Because we didn't shade this one in down here, this white one, but we do have equal sides. So do you think it's going to be true about these 2 angles? They are. So if you want to, you can go ahead and mark those 2 equal as well. Again, beneficial with some problems. I just want y'all to see that if the isosceles triangle is there, we can use those properties. So what can we say about this angle, this full angle, and this full angle? Not equal 90. Let's say the red one was, I don't know, let's say this is 50. This is 50. And I'm just making up numbers, okay? This is 20 and this is 20. What can I say about those two angles? They're equal to each other, right? So on the right side, you only have one pair of opposite angles that are congruent. And it's gonna always be the ones between the sides that are not equal. So if you look closely, this side, let me use a different color. Darn it. Here we go. This side and this side were not equal. And that angle in between them and the one opposite of it are the ones that are equal. Same thing here. This side and this side are not equal. The angle between it and the one opposite of it, these are the ones that are equal. Because if you think about it, because you guys really want to think about it, right? If you think about it, if I decide to fold my kite along this dotted line, wouldn't those two angles match up perfectly? So they would be congruent triangles. We can say they're congruent by side angle side. So those two angles have to be equal. The top and the bottom won't be, just so y'all know. This one will not be equal to this one. Will not be equal. Okay, let's apply the last piece. All right, so there's a bunch of numbers inside, nothing on the outside. What do you know about the diagonals here? You want to read the boxes. Which of these tells me information about the diagonals? The first box, the middle box, or the last box? The middle one. The middle one tells me that they create a 90 degrees, okay? Because with some students, I've noticed that when they ask for help, it's just that they're not reading. You need to read your notes. Like, look, read it. What is that telling you? All right, so this is 90 degrees. And then it says, find the angle. Isaiah pointed this out to me, sorry. That went with that. When I shortened your notes, I accidentally put the wrong shape on the wrong problem. Okay, so it says find x to y, and then find w to x. Find x to y, and then w to x. All right, so how would I find x to y? How would I find this side? If it's a right triangle. Pythagorean theorem, good. All right, so we're gonna find this side. I'm gonna call it m. Let's do 8 squared plus 24 squared equals m squared. Let me know what you get for m. Just Pythagorean theorem. A squared plus b squared equals c squared. Let's solve for that c. What do we get? What was it? 25.29? We all agree? 25.29? All right. So this is 25.29, and that was the measurement between x and y. All right, let's do the same thing for w to x. So this side here. So what numbers am I using to find w to x? 6 squared plus 8 squared, and we'll call that n. Just trying to use lowercase letters of letters that aren't there. So what would that one give me? 10? All right, and that is x to w. All right, and of course I can always extend this, right? Now that you know two sides, could you find me the perimeter? You could, right? Because if you know this side, what other side do you know? Yeah, so what would be identical to this one? WZ, so there's 10 and 10. If you had to look for this one, what's this one identical to?
X to Y.
25.29, right? Because it's the same triangles. This was 8 squared plus 24 squared. This is also 8 squared plus 24 squared. So don't go doing the extra work, right? Because they're equal. And then y'all can find the perimeter there. So yes, you may have a perimeter problem. Just do Pythagorean theorem, find your sides. You guys are just gonna add there. All right, and then let's look at the next one. On the next one, and again, I apologize for my mistake. That goes with that one. It says, if FGHJ is a kite, find me the measurement of GF to J. GF to J. They want to know this one. What else do we know about that angle? It's equal to the other one, right? Because they're in between those non-equal sides. Those are the only ones that are equal. All right, I had you guys memorize this. The four-sided shape always equals 360. Good. So let's add everything. We have 2x's plus 128 plus 72 equals 360. Let me know what you get for x. All right, what'd y'all get for x? 30? 80? Did y'all get 80? Waiting for someone to nod to confirm. Yeah, okay. So x is going to be 80. Good. All right, let's see. Do you feel you need to do... Let's just talk about this. All right, so this was identical to the one we did, except what angles are equal here? And you can just give me the letters. What angles are equal? X and Z. So this one, again, would be 121, and you'd be looking for this angle. So then you add them all up and then set it equal to 360. So I'm just going to set them up just so you have it written out. And then you would solve from there. All right, let's look at the last one. Also a kite. So keep in mind that one of your diagonals will always be bisected. It's the one that separates your two isosceles triangle. So do you think the diagonal that's bisected is M to P or N to Q? Which one do you think is bisected? Do you think this one is cut in half or do you think this one's cut in half? It's actually M to P. It's going to be this one is always going to be congruent to this one. All right, now we can do Pythagorean theorem to find the top ones. Right? Let's see. So this is supposed to be a 10. That way you can figure out the other side. So this is just another one where you would do Pythagorean theorem. The only thing, the 10 should have been there, realizing that I accidentally shrunk that box, but the 8 wouldn't have been there. So just know that that's the one that's bisected. So if you want to come up here and you can add it, you can say that this diagonal, it's bisected. It's the one that goes through the congruent angles that's going to be cut in half. You can kind of think about it as that whole folding piece, right? If I fold it along this line, these two should be the same lengths. If I was to fold it along this line, would this triangle match up perfectly with this one? No. So that one won't be bisected. Another one way to think about it if you're unsure which one's which, okay?